What's up, y'all? It's your boy, Mr. B. Here to do some more sine and cosine, so let's get to it. What we're going to look at today is what does this 3 do to our graph of sine or cosine. So how this works is we're going to still use the order of operations. So we're going to do the cosine part first. So what that looks like is for 0, for example, we're going to do 3 cosine of 0. And the cosine of 0 is 1. So 3 times 1 gets us 3. So for here we get 3. Next we're going to do pi over 6. So we're going to do 3 cosine pi over 6. And the cosine of pi over 6 is the square root of 3 over 2. So if you're like me, I like to just have that note, because the square root of 3 over 2 is 0.86. So 3 times 0.8, and it's actually 87. And so that gets us, times 3, gets us 2.6. So that is our pi over 6. So 2.6. I'm just saying pi over 4. We're going to do 3, let's see if I can fit this in, times cosine of pi over 4. And the cosine of pi over 4 is the square root of 2 divided by 2, which is 2 divided by 2 gives us 0.71. We'll round it there. So 3 times 0.71 gets us 2.13. So that's what's going in there. So you're going to do that. Let's see if I can expand this. 2.13. So you're going to do that, and you're going to complete this table for both 3 cosine and 1/2 sine. So that one you're multiplying it by half. Here you're multiplying it by 3. So pause the video, and you're going to complete this table. It's the same as last time. It goes all the way down to 2 pi. So it's important to know by this point you should have the unit circle memorized. If you don't, you can Google blank unit circle. Work on filling that out to the best of your knowledge. The most important thing we know here is cosine is our x value of each point, and sine is our y value. So pause the video, fill in that table, and then unpause when you're ready. So here's what I got for the first part of my graph. Check your answers with this. And it's going to continue the same sort of pattern. Cosine is going to go positive to negative and then climb back up positive. Sine is going to go 0 to positive 1/2, back to 0, and then it's going to go negative in that same sort of pattern. So what I want you to do is you're going to look at these graphs, or you're going to look at your table, and you're going to graph them on a graph. So you could sketch this graph here. Let me move mine up just a little bit. So you're going to sketch this graph, and we're going to graph it. So let's start it together. So the important thing with these is that we want to make sure this fits in our graph. So we're at 0 here, and our biggest value here was 3, so we can just mark this as 3. And our smallest value was -3. So now we know our whole graph's going to fit on it. And then we're going to graph these from 0 all the way to 2 pi. So 0 was 3. And then I want you just to graph your points. So remember that pi over 2, there's these little ones in here, which would be pi over 6, pi over 4, and pi over 3. Those 3 are hidden in there. Maybe I'll write it a little bigger for you so you can see it. But those middle ones are very important in getting good shape for our graph. So this one is pi over 6, pi over 4, and this last one is pi over 3. So pause the video, take some time, plot those points, and see what kind of graph you get. All right, so here's what I had for my graph, and it's asking how did the 3 affect the graph of sine of x and cosine of x? Well, normally with cosine of x, what was the biggest value we got? What's the biggest cosine could be if there was no 3 there? Yeah, it's 1. So normally it would go here and go down, and then it would meet at that same maximum, and then come back up to 0, and go back to that graph. So what we call it, we stretched it vertically. It was a vertical stretch. You took this and you pulled it apart. So instead of from 1 to -1, it went from 3 to -3. So let's see if that holds true with sine of x. So what we're going to do now is we're going to graph this 1/2 sine of x. And let's just, for the sake, say, let's just go from 1 to -1. So this would be 0.5, 0.25, -0.25, and -0.5. So I want you to, we're gonna mark those spots again. That's the first thing I want you to do. So this is pi over 6, pi over 4, and pi over 3. And you're going to graph the points of 1/2 sine of, and this is called theta. I don't know if we've talked about that, but that's theta. It's just another way of saying angle. So we had 0, 0, and then at pi over 6 we had 1/2, 0.35, and then we got there. So you're going to take your time to graph that entire thing. So once you're ready, unpause the video. So let's take some time to do that. All right, so here's what I got for mine. So you can see that normally we would have 1 and -1 as our maxes, and we'll go up through the same 0 down, back to the edge. So instead of stretching this 1/2, compressed it. Now the reason that is normally with sine of x, what number's hidden in front? You guessed it, it's always that hidden 1. So that's why 1/2 is smaller than 1, so it compressed it. All right, just so y'all know, this is like take 4 because I can't do this right, but we're going to reflect. And how did the 3 and 1/2 affect the graph of sine of x and cosine of x? Well, the 3 expanded our graph, and the 1/2 compressed it. Why do you think this is? I want you just to take maybe 10 seconds to think of what is this 3 and 1/2 doing to the graph? The way I think about it is I think every value here, every value of cosine of theta is multiplying by that 3. That's why it's stretching by 3. You could have a different way of thinking about it. That would be A-OK. So let's look. So here is an important note to take. So what it says is the difference between the maximum or the minimum and the average. So we call that average. In this case it was 0, but that 0 can move like we learned last lesson. It's called the amplitude. So what's the amplitude of each graph? Well, the first one was 3, and the second one was 1/2. All right, let's close out our lesson here. Let's finish up strong. So let's answer these 2 questions. Question number 1. What would the amplitude of y equals 5 sine of x be? How do you know? Take a second to answer that. And our last question of the day is, what would the amplitude of y equals 1/5 sine of x be? How do you know? Take a second to answer that question. All right, thanks for joining us. Make sure you smash that like and subscribe button. Have a good day, and let's get on to lesson 2 next time you log in.